Okay, so let's come back together for this demo. Lesson number 23, first day of something called the quadratic formula. Show of hands if you've seen the quadratic formula before. Looks like most of us. Raise your hand if you think you still have the quadratic formula memorized from some past math class. Maybe a little bit. Okay, in this lesson we learn how to use the quadratic formula to solve quadratic equations. It says the demo is long, and let's go through this first page quickly. So here's how quick we're going to go through it. Bam, 176. So taking a look at number 3, says graph A, that's this parabola here, represents the parabola for the quadratic equation, y equals x squared plus 5x minus 6. There's the graph. If I gave you guys a couple of minutes, you could come up with that graph on your own just from the equation. That's exactly the kinds of things in the activity that you were working on. So looking at this picture, if I wanted to just put a dot on the x-intercepts, can you do that? Put a dot on each of the two x-intercepts for this graph. And do you guys buy this thing that's written out here? The two x-intercepts look like they're at -6, 0 and 1, 0. Yeah? Okay, and so here's an easy question if we know how to answer it. It says, using the graph, identify the solutions to the equation 0 equals x squared plus 5x minus 6. Now that equation looks an awful lot like that equation. What's the only difference? Y has become 0, yes? So apparently, to solve this equation, I'm just asking you to look at the graph and figure out where y has become 0. And if you just look on the parabola, the only 2 points where y is equal to 0 are those two x-intercepts, the 2 points you just put a dot on, right? And so it's easy enough, but it's an important connection. If you are looking at 0 equals instead of a y equals, then we're just talking about x-intercepts. That's it, because x-intercepts is always change the y to a 0. So the answers to this particular equation are x equals what? -6, and also x equals 1. Those are our two answers to that equation. Okay. All right. Part B says, how can we find these solutions algebraically, that is, without relying on the picture? Well, we can factor the right-hand side of that equation. And let's give this a shot now. Just to save time, I'm just going to write the answer here. So this guy becomes x, what do we have here? X plus 6, x minus 1. So go ahead and write that. That came from doing the 2x2 box. We're not going to take our time to do it right now, but that's what you get when you factor. And once it's in factored form, what do we do to solve that equation? Each of those equal to 0, right? So let's try that. Either x plus 6 is 0 or x minus 1 is 0, right? The beauty of having it factored equal to 0 is that you can then split it up and just solve two much simpler equations. So how much is x in the first one? -6. X in the second one, 1. Super. Same answer as we just got. Okay, same idea, different parabola in number 4. It says graph C, that's the one pictured down here, is the parabola for the quadratic equation y equals x squared plus 2x minus 5. New equation, new picture. Go ahead and put dots on the two x-intercepts here. And here, maybe it's not so clear what the numbers are. I've written down it's about -3.4 and about 1.4. Does that seem reasonable? But there's really no way to know looking at that picture. Was it 1.4 or was it 1.3, 1.38721? Right, we're probably not going to guess that by looking at the picture. So, okay, maybe algebra will come to our rescue because the graph is letting us down a little bit. So let's see, if we were going to solve this equation, right, the 0 equals x squared plus 2x minus 5, then we'd really like to factor, right? And we can put some stuff in there. I'm going to build a -5. What does it have to be? There's only two ways to build that -5. Maybe a +5 and a -1. Or the other possibility is a -5 and a +1. The problem is neither of these things gives you that +2x in the middle. It just doesn't work. And if you try the box method all the way out, you will find nothing works. Remember in the box, we fill in the two diagonals, and you're trying to find things on the other diagonal, and we would find nothing that works. So what that means is that this one here cannot be factored. We just can't do it. We can estimate the solutions to the equation. 0 equals means find the x-intercepts. So what are our estimates for the answers to that equation? So we can estimate them, but we can't know them exactly because the graph doesn't have enough detail for us. And we can't factor it, so it seems like we're kind of stuck. So we need a new tool because the only tool we have algebraically is factoring, and this one does not factor. So here's the new tool. It's called the quadratic formula. Here it is, a quadratic equation written in the form ax squared plus bx plus c equals 0. It's got to be in that standard form, which means 0 on the one side and then descending order on the powers of the x's. Then the solutions to that equation are x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. That glorious thing is the quadratic formula. Okay, here's the good news. I will provide you with this formula on any quest and test where you'll have to use it. So you don't need to memorize it, but you do need to be able to use it. So let's try that here. Okay, so first thing, the symbol plus or minus is just a shorthand way of writing the two separate things. The plus or minus was right after that negative b, and so you can see here, it's negative b plus on the one hand, negative b minus on the other hand. Instead of writing those two things out as two separate numbers, which is what they are, we just use that shorthand plus or minus to save a little bit of writing, okay? But plus or minus shouldn't be confusing. It's just a shorthand way of saying two different things, but we're gonna kind of make a contraction, push them together. Okay, so it says memorize the quadratic formula soon. You don't need to, but it might make it easier to do homework and stuff like that. If you go on YouTube, you can find people singing the quadratic formula to the tune of Pop Goes the Weasel. But what I'm interested in is having us use the quadratic formula. So let's move to the next page. Here's our equation, 0 equals x squared plus 2x minus 5. This is the one that we could not factor a second ago. This is the one where we should get answers right around 1.4 and negative 3.4. Let's give it a shot. Step 1, if necessary, put the equation in standard form. Notice that we need one side equal to 0. Do we have that already? We do. But it's important, if you don't have it equal 0 in the beginning, you do work to make it look like that. Step 2, identify and write down the values for a, b, and c. Easy with just a tiny bit of practice. A is always the number touching the x squared. It's invisible in this case. 1. B is always the number touching the x. C is always the number without any x's next to it. Negative 5. It's really important to grab that negative sign. In fact, grab any negative signs. Those are A, B, and C. Any questions on grabbing those numbers? Okay, so now we get to start plugging those things in to our quadratic formula. So it's already done actually for us there. So where can we go? Can we use some space down here? We're just going to redo the stuff that's typed out, but this will make us feel like we're doing something here. So let's just write the formula just so we have it right in front of us. Negative b plus or minus square root b squared minus 4ac all divided by 2a. So copy that. I think it's probably also written on this page here near the top. And I'm just going to bring down the A, B, and C. You might put them here too, so they're nearby. So 1, 2, and negative 5. Okay, here we go. So just substituting every one of those letters, A, B, and C, are going to get changed to numbers. So it says negative b. All right, this is going to be overkill, but I'm going to put parentheses around every single number that I substitute in. So there's a negative. What was the value of b? 2. Putting it just like that. You don't need them, but sometimes you do. So I'm just going to put them all the time. The next symbol I see, plus or minus. Next thing I see, big old square root. Then I see a b squared. Anytime I change a letter to a number, I'm putting parentheses. I recommend you do too, at least in the beginning. B is getting squared. What's b? 2. Now in your head, you probably could have just written 4 there. It's fine as long as you're 100% accurate, but any little mistake with a sign messes everything up. Better to go a tiny bit slower and get it right than to save a few seconds and get it wrong. Next part's minus 4ac, minus 4. A and C are numbers. I'll put parentheses. How much is A? 1. How much is C? Negative 5. Careful with those signs. Whole thing divided by 2A. A is a number, parentheses. How much is A? 1. Okay, so that's the first step. Change all the letters into numbers very carefully. At this point, it's really just arithmetic. It's not to say we won't make any mistakes, but that's all that's left is arithmetic. Okay, equals negative 2. Now I'm going to do all my work to get rid of these parentheses. Negative with a 2, we don't need the parentheses at all, just negative 2. Plus or minus, square root of. 2 squared becomes 4. I recommend dealing with the negatives first before you get lost in the 4 times the 1 times the 5. Just think about the negatives. That is a subtraction with a single negative. That is 2 negatives, which becomes plus. So I just do this completely separately of the numbers. I've seen too many people get the wrong sign there. So just deal with the sign separately. And now I'm ignoring all of these negative signs in here. 4 times 1 times 5 is 20. Divided by downstairs, 2 times 1, 2. So far, so good. If we're doing our job every time we rewrite, it should look a little bit nicer. And this certainly looks nicer than where it came from. Equals negative 2 plus or minus square root of, inside there, 24. Divided by 2. Don't be afraid to do a lot of copying and make one small change. It's the most accurate way to do these kinds of problems. Okay, oftentimes you would stop here, but if we can simplify the square root of 24, then we have to. We're going to go to the calculator in a minute, but I first want an exact answer without the calculator. Negative 2 plus or minus, remember this idea, lots of copying. 24 is the only thing that's getting changed. It's going to get replaced with a perfect square times whatever is left over. What perfect square goes into 24? 24 is equal to lots of pairs of numbers multiplied, like 8 times 3. But the square root of 8 isn't helpful to me, and neither is the square root of 3. 4 is helpful to us, right? So 4 times, and then whatever's left over to make 24, 6. And then that square root of 4 comes outside as 2. Remember doing this? So I'm copying everything else. Negative 2 plus or minus. We said the 4 comes out as a 2. What's still inside? 6. And then that's divided by 2. So you guys probably ran out of space. Just hit the extend page button at the bottom. Okay. And a few classes ago, we talked about simplifying things that look like this. We would take this single thing and split it into 2 fractions. I'll write it. Hopefully it'll look familiar. But it's negative 2 over 2 plus or minus 2 radical 6 over 2. You remember doing that? Split it up right at the plus or minus. And that gives us the ability to simplify those fractions separately. First guy becomes negative 1 plus or minus. Second guy becomes just square root of 6. So those are our exact answers, simplified as far as possible. We're going to type them into the calculator in a second. Any questions on that? I've got calculators I can loan out. I don't want you using your cell phone here because you can't use it on the Quest. So I want to make sure we can do what we need to do on the calculators you will have in your hands. So if you have one of these, just use it. But if you're used to using a cell phone, yeah, let's not use that. Yeah, so no cell phones, no graphic calculators. Do you need one, Nick? Nope. Who needs one? There. Who else? There. Good. Practice on this instead of this. Okay. All right, here we go. So let's make sure that we can Let's make sure that we can type this thing into our calculator. Okay, so here's my calculator. The buttons that I press might be in a slightly different order from the ones you press. I don't know. -1 plus or minus √6. So let's see, what am I typing in? 1 and then a negative sign. Plus or minus, we can't do them both, so we just have to do one at a time. So plus the square root of 6 in some order. You know what, I'm bailing on this calculator. You'll see it better if you, you're not allowed to use one of these, but this, you'll see the keystrokes better. So -1 plus the square root of 6, 1.449. And then the other answer is -1 minus the square root of 6, so we just type it again. Then we get -3.449, okay? Just to remind you, these are the numbers that we expected looking at the graph. We said it was about 1.4 and about -3.4. These are much more accurate answers than we could have gotten on the graph. Okay, now, this one was particularly easy or friendlier to type in because all the fractions disappeared, but that is usually not the case. So I want to make sure that we can type it in when it's more complicated. So can we go back and type in, let's go back and type this guy right here. We're going to get the same answer, but it's just more involved to type it in. So what I need to do is put parentheses around the entire numerator. So you guys should have a parentheses button on your calculator. That's the first thing we type. Everybody find it? Open parentheses. Okay, and then we're typing -2 plus 2 square root of 6. Now, I don't know about your calculator, but my calculator is trying to outsmart me, and it put in parentheses right before that 6. I didn't type that. So I have to close the 6 parentheses, and then I have to close the numerator parentheses. So I need 2. Do you guys need 1 or 2? You need 2 because your calculator also inserted a, so just have to be careful. That is the entire numerator. It's getting divided by 2. And we get exactly the same thing as before, but I just want to make sure we can type it in. Usually it's this complicated and not as simple as the 1 plus or minus √6. Same idea, go ahead and try the other one. Just try from scratch. Same thing, but do the minus instead of the plus in the middle. Okay, so if we have any issues with typing stuff into the calculator, I'll deal with them during activity time, so I don't want to do that right now, but I can help people individually when we're in the activity and also next class. For right now, we are moving on, but I just want to point out that I've given you a couple of screenshots here for when you're trying this at home, right? So this is the most complicated thing I have asked you to type in, and I need to make sure you know how to do it. Questions on that? Okay. Next page, last one we'll do together here, number 10. So here's the equation we're trying to solve. -2x squared minus 7/3 x equals -1. What don't you like about that? Fractions. Everything. You don't discriminate at all, just wholesale, get rid of it. You're welcome to use the quadratic formula on this thing in its current state, as long as you get the 0 on one side. But why don't we make our lives easier and get rid of all the fractions? What can I multiply everything by to get rid of the fractions? It's 3, right? The only denominator I have is a 3. If I multiply everything by 3, that 3 will go away in the denominator. So that's a good first step. Not mandatory, but recommended. So multiply everything by 3. The 3 is going to come in and distribute. What do you get when you multiply the first things? -6x squared, that's there. When you multiply the 3 by this -7/3 x, it's really tempting. Some people are going to put 21x, but that's not right. The whole purpose of putting that 3 there, this is the calculation we're doing here. What's the whole purpose of putting that 3 in the front? Is to get rid of the fraction. So you get rid of it, and it's not there anymore to make a -21. It just disappears. That's why we put it there. So that negative 7/3 x becomes what? Negative 7x. Really easy to forget to do the negative 1 times 3. That's negative 3. Okay. All right, so it's looking better because we got rid of the fraction. What do we still need to build before we jump in with the quadratic formula? This is 0. We've got to have equals 0. So let's add that 3 to both sides. And we add that 3 to both sides and get this. Negative 6x squared minus 7x plus 3 equals 0. So far, so good? Okay, so let's give this one a shot. We're going to do the quadratic formula. First step is to identify a and b and c. Remember, a is the number touching x squared. What is it? Negative 6. B is the number touching x. Negative 7. Make sure we grab those negatives. We're doing that right. And then c is the constant term. Positive 3. That's good. So that's your a, b, and c. Strongly recommend you write them out. Okay, so let's try the quadratic formula here. There it is written out for us. Negative b. I'm just going to do something real quick. Plus or minus square root of b squared minus 4 times a times c, all divided by 2a. So just a possibility to start every quadratic formula with this. Just give yourself the skeleton. Lots of empty parentheses, then it becomes a fill in the blank. Okay? If you put all the parentheses, you're going to be a lot more accurate with all of your sign stuff. Pluses and minuses will not get lost if you're really careful about those parentheses. So negative b, what's going in the first parentheses? Negative 7. Plus or minus, what's going in the next parentheses? Negative 7. It's really important to put that there because I've seen this too often. Negative 7 squared, b squared, right? How much is our thing with the parentheses when we square it? That's 49. That's right. If you do this squared, does that negative get squared? No. The 7 is the only thing getting squared here. That's 49 with a negative in the front is negative 49. It's not right. It should be positive 49. This is part of why I insist on all the parentheses. Minus 4ac. A is negative 6. C is 3. 2a on the bottom, that becomes 2 times negative 6. Okay, equals. Let's do all our calculations here. Negative 7 becomes 7 plus or minus square root of negative 7 squared, 49. I really think you should deal with the signs separately. Is this going to become a plus or a minus? That's plus. And now we don't have to worry about the signs. It's just the numbers. 4 times 6 times 3. That's 72. All divided by negative 12 on the bottom. Okay. And now lots of copying as we make one and only one change. 7 plus or minus square root of. We're just smushing that together. What do we get there? 121? Now for some quadratic formula problems, this is the final answer. But if we can do anything further with that square root, we have to. And the square root of 121 is just 11. So we just need to change it to 11. Right? This is different from the 24 we had before. 24 was not a perfect square, but we played with it a little bit and reduced it. But 121 is a perfect square. 7 plus or minus 11 divided by negative 12. So I show you this example just because I want to make sure we know how to finish it in cases like this. To be honest, if that guy turns out to be a perfect square like it was in this case, it means the original problem factored. We could have factored into 2 sets of parentheses using the box, but you might not know that going into the problem. Honestly, if the thing factors, it's probably quicker and more accurate to factor than to do the quadratic formula. But just in case you miss that and you do the quadratic formula anyway, you'll still get the right answer provided you know how to finish. So here's how we finish. In other problems, at this point, we'd split into two fractions. That's not helpful here. We are going to split this, but we're splitting it into two completely separate calculations over the plus or minus. It's 7 plus 11 over negative 12 and 7 minus 11 over negative 12. See it? Just writing out the plus or minus separately. Frankly, there's no reason to split into two fractions. Like you could do 7 over negative 12 plus 11 over negative 12, but why? 7 and 11 is just 18. So let's just smush them together. Make 18 over negative 12, which reduces to negative 3/2. All right. Go ahead and finish that one. 7 minus 11 over negative 12. So what do we get? Negative 4 over negative 12, which is 1/3. So those are our two answers in this case. Negative 3 over 2 and positive 1/3. Questions on that? Okay, so we have 3 minutes left, which is plenty of time for you to do at least one of these quadratic formula examples on the next page. So let's see how far we can get. We're looking for both exact answers, which probably have radicals in them, as well as decimals. And if there are any questions on how to type stuff in on the calculator, just let me know. A little question about the first one. 3x squared. Everybody got it? 3x squared where that hole punch is? 3x squared.